Okay, on that last video we figured out how we come up with our formula for area of a regular polygon. So just to recall, it is 1/2 perimeter times the apothem. We're going to work out a couple of examples here together, and then I'll have one more video with a few more examples and also talk about composite figures. So this one here is asking about a regular pentagon. Before I even read the rest of that, this is a geometry class. We're very visual people in here. Let's draw ourselves a picture so we can see what's going on. So you don't have to be perfect at drawing regular polygons. Just draw something that slightly resembles what we're working with. Okay, well there's my best version of a regular pentagon. It's got 5 sides. Alright. Also, for all these regular polygon problems, I would always just draw the center. So here they're telling us it has a perimeter of 40 centimeters. Now, if you have a perimeter of 40 centimeters, and forgive my handwriting, my printer wasn't working this morning, so sorry, I'll work on it for next time. So if I have a perimeter of 40 centimeters, that's going to help me figure out the side lengths. Also, one thing it tells me is the value for capital P. Our formula, A equals 1/2 capital P times little a. So I already have the perimeter, I just need to find that apothem. As I mentioned before, that's usually the tricky part to find out. Okay, so what are we going to do? Well, first we need to find the side lengths. If I have 5 sides and the total perimeter is 40, well, 40 divided by 5, let's see, I think we could do that, is 8 centimeters. So that means each and every side of this regular pentagon is going to be 8. I always work with this bottom one. You don't have to. I just think it's kind of more intuitive than working with any other side. So I'm going to draw my apothem. I don't know what it is. I'll call it little a. And then I'm going to draw my radius. Okay, so if every side is 8, one thing I failed to mention in the first video was the apothem also bisects every side of your regular polygon. So if every side is 8, that's going to be 4. And so we have a right triangle. Okay, well, we should know how to work with right triangles, all kinds of different scenarios. This is going to be a trigonometry problem. You have 2 choices. You can either find this angle here and use SOHCAHTOA, or you can find this angle. Either one, doesn't really matter. I'm going to find this one here because we have a formula for the sum of interior angles, if you all remember from way back when, n minus 2 times 180. That will give you what they all add up to, and then to find each individual interior angle for regular, you divide by n. So if you did, let's see, 5 minus 2 times 180, so that's 3 times 180, and then you divide by 5, because I plugged in a 5 for n. Let's 540 divided by 5, that's going to be 108 degrees. Okay, so that tells me each of these angles is 108. But this isn't an entire angle. I have that radius drawn in. The radius is going to bisect all of those angles. So if every angle is 108, okay, 108 here, 108 there, blah, 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 this is going to be 54. Now, if you don't like using this formula, that's totally fine. What you can do is do like a full rotation, 360 divided by 5, and that'll give you like these bigger triangle angles, and then you can divide that by 2. You get the same answer either way. So you're not going to get a 54, you're going to get the complement, which is 36. What I'm saying is you'll get the same answer for your apothem regardless of which way you do it. So now that I have an angle, the opposite side is the apothem and the adjacent side is a 4. That is going to be a tangent. So tangent of 54 equals little a over 4. And then to solve these kinds of equations, we know to multiply both sides by 4. So in my calculator, I would type apothem equals 4 times tangent 54. Make sure you're in degree mode. And when we type that in, I did that a little bit earlier. Hopefully you all can see, kind of, sort of. That gave me about 5.5. 0.5527682. I'll just go with 5.5. So that's my apothem. Alright, well, now I have everything I need. They gave me the perimeter. I just found apothem. Plug it in, see what I get. Area for my regular pentagon is going to be 1/2 of 40 was my perimeter. and apothem is 5.5. So that's 20 times 5.5. Oh, and my brain is not working right now because I've got 10 million things on my mind, but I should get 110, I think, when you're done. So close to 110, they told me centimeters. Okay, so that came out nicely. Usually we want to wait till the very end to like round off. I just rounded off here, but usually we want to plug in this value for the little a over here. And this is totally fine though. Okay, so let's work one more with a regular polygon. This next one is going to be a regular octagon. As I mentioned, we're in geometry, so anytime they give you a verbal description, go ahead and draw yourself a diagram. It doesn't have to be perfect. It's got to have 8 sides. Think of like a stop sign. Oh, this is terrible, but I think you'll get the idea. Wow. Okay. I'm ashamed, but it's the best I can do. So I'm going to go ahead and draw my center. Now this one's a little bit different because they told me in this case the radius, they didn't tell me the perimeter. So my formula, like I said, I want you guys to write out that formula for every area problem that you work. That way you don't have to memorize them a whole bunch right before we take a test. You will have already memorized them just by writing them so many times. So area is 1/2 perimeter times apothem. Here I need to find both perimeter and apothem. They told me the radius is 16 feet, so I'm going to draw a radius of 16. I'm going to draw my perpendicular, call that little a for apothem, and then I'll put, I don't know, an X there. Hopefully that's legible. Looks like kind of. Okay, so I need to figure out the value for a and the value for X. That's not a 9. That's an A. Okay, so I'm going to take the same approach, use a trigonometry problem. Here I'm going to have the hypotenuse, and I'll be looking for either adjacent or opposite, whichever I choose as sine or cosine. So finding this angle here, I'm going to first find the measure of each angle, n minus 2 times 180 divided by n, and if you work that out, you should get 135. Okay, so that tells you the measure of each interior angle is 135 degrees. This radius is going to bisect that, so this angle is 135 over 2, or if you want to use a decimal, it should be 67.5 degrees. Okay, so we're going to now be able to set up our equations using sines, cosines, or tangents. If I'm looking for A, that's opposite, 16 is hypotenuse, so I'd use a sine. So sine of 67.5 is little a compared to 16, and we all know how to solve that. Multiply both sides by 16, so apothem is going to be 16 sine of 67.5 degrees, and then to find x, that's adjacent to 67.5, and 16 is hypotenuse, so I'm going to do cosine of 67.5 equals x divided by 16. Same solution technique, multiply both sides by 16. Okay, so x is going to be 16 cosine of 67.5. Wow, that's a mouthful. So I have the apothem, okay, good, and I have x. X isn't the perimeter, but it's part of the perimeter. X is half of one of my sides, and if I have 8 sides, well, what I'm going to have to do to get perimeter, so this tells me that capital P for perimeter, this is half of one side, and I'm supposed to have 8 altogether, so I should multiply by 16. Okay, so just one more time, I know that might confuse some people. The reason why I have that 16 is, well, I've got one x here, and another there, so there's 2 there, so 2, 4, 6, 8, 10, 12, 14, 16 x's would give me my full perimeter. Okay, so now I have all the stuff I need. Now it's calculator time. So area is going to be 1/2, oh wow, 16 times 16, 256, cosine of 67.5 degrees. So 1/2 perimeter times apothem, which is 16 Sine 67.5. As I mentioned, it's best to really wait till the end to do any rounding. So I'm going to type all that in my calculator all at once. So 0.5 times 256. And make sure you're in degree mode because that'll throw all your answers off if you're not. Also, make sure you close any parentheses whenever you put the angles in for your sines and cosines. Let's see, 67.5 should look like this. I know it's kind of difficult to see. Oh, maybe, yeah, a little blurry. Oh well. Oh, it doesn't even show the beginning. So 0.5 times all that. So let's see what that tells us. So about 724.1. So that comes up to be about 724.1, and our units were feet, so we should say feet squared. Oh, and on that last one, I forgot to square my units. That regular pentagon should be centimeters squared. Okay, I'll have one more video with some more examples and composite figures.